Infrared welding is the process of joining thermoplastic components using quartz glass infrared emitters. The surface of the plastic components is heated to a molten state and then joined by being pressed together. The infrared process is a non contact assembly method allowing for particle free welding. Time and power is controlled in this precise process, resulting in flexibility for various materials and joint contours. HA Industries is a leading provider of infrared welding automated machinery. They have been doing business since 1990, starting as a partnership to provide better quality products than currently available at the time. Since then, they have grown by working with companies of all sizes, from a small piece of equipment to multiple machines and complex systems. These guys have the capability and knowledge to handle just about anything. In 2022, Movitherm joined forces with HA Industries to support the thermal seal inspection of HA's infrared welding line. In this episode of the Thermal Review, we are thrilled to have Mark Erndt, the president of HA Industries, and of course, Marcus Terran, the president and CEO of Movitherm. Welcome, guys.
Thanks, David. Welcome yourself.
Yeah.
Thank you. Good to see you guys. This is a great day. I've really been looking forward to this episode of the Thermal Review, and of course to have you, Mark, from HA Industries, joining us here today, and Marcus to provide some perspective on how this partnership has been supported through thermal imaging technology, which is what this podcast is all about. So I thought we could start off today, Mark. Perhaps you can tell us a little bit about who HA is. I covered it briefly in our intro, what you guys do, and maybe even some of the markets you serve.
Well, thanks, David. We are a full system integrator to the automation world. What that means is that we can do the small standalone equipment, or we can do the large cells where it's multiple robots in those cells. Whatever that customer needs, we're pretty much turnkey with what we do. We can control our timeline within our four walls. We definitely have taken a strong interest in IR welding, because IR welding allows you to do contoured parts. And right now, that's the first technology that's came out there to be able to weld contoured parts. And we're excited about it. We've embraced it. And we have a lot of different types of things that we're R&Ding right now in our R&D department to further the whole IR welding.
I had the opportunity to visit your facility there in Michigan. By the way, that's where HA Industries is based out of. We're kind of covering the entire U.S. continent today, or countryside. Me on the East Coast, Marcus out in Irvine, California, and you right in the middle in Michigan.
We got it covered.
There you go. But you guys have some pretty impressive capabilities. I don't know if you can talk about that a little bit, but I saw some machinery there that was quite impressive. This stuff is big time.
Customers come to us because they have many widgets and clips and fasteners that's got to go on the back of the attachment schemes to any part that they got in their facility. We're helping reduce some labor. At the same time, we are actually giving them a vision system that detects anything within that cell that doesn't meet the criteria of a good part. So they have assurance that when the part comes out of our equipment, it's ready to ship to their customer, because we have satisfied all the build requirements on the backside of that part to be able to attach it to the vehicle. And we can do parts as small as a coffee cup, all the way up to as large as a full-size vehicle. So there's a lot of opportunity here at HA. As you had pointed out, David, we can do it all. We're system integrator where we're able to take a product line almost from the cradle to the grave with the process.
You touched on something just a little bit, Mark, with regards to sounds like automotive, and that's what I'm familiar with when it comes to Industries and one of the markets that you serve. And I'm sure you have NDAs, in place with all your clients. But are there other industries outside of just automotive where you guys are building your machines and helping folks automate things?
Yes, we are in the energy market where the windmill turbines are storing energy. We help build those storage units. So we are in the energy market. We're in food and beverage market. We're also now just crossed into the medical uh, market. We're doing a production unit on in the medical industry on a therapy platform um, where it allows the patients to be able to do their therapy either at home or in a different isolated section of the hospital because this thing's a portable and mobile unit. So we're excited about that. We also have been in the defense market as well.
Hmm. Wow. So quite a broad spread. Interesting. Again, as I stated, I was really familiar what you're doing in the automotive space, but yeah, it sounds like you cover quite a broad spectrum. Um, let's back up a little bit. Maybe we can talk about this a little more because this infrared welding is interesting, and it's not the only method. Maybe there's various ways to bond plastics, right?
Right. Yep.
What are some of the different methodologies and for bonding plastics, and maybe you can help our audience understand the infrared advantage, if you will. Why is infrared welding so great?
The infrared welding, really the most important thing that we have has been able to do the thermal imaging camera because it gives us a real snapshot in real time of what's going on with that weld. We're able to watch the trending of that weld and understand where that's trending off a nominal to be able to make adjustments to the machine so that we always are having a harmonized weld and the two surfaces are actually, we can see that in real time in a thermal imaging camera. So for us, it understands that when that part comes out of there, we know it's a good part in real time.
Hmm. Awesome. Marcus, you've been doing inspection systems for, gosh, 20 plus years now. Um, maybe you can explain a little bit about how Mark touched on this infrared inspection and why it's important. How does it work?
Yeah, so infrared welding is similar in terms of being a non-contact method, right? Getting heat into a part, whereas the thermal imaging is also non-contact, and we can measure the thermal radiation coming from that heated portion of the piece coming back to the camera. So that's kind of what we utilize. So we can actually see the actual temperature profile of the weld in our inspection system and evaluate whether it has reached the appropriate temperature for creating a strong bond before parts being, put together, essentially.
So, what's the implication if let's say you see a cold area, or let's say that the plastic doesn't melt to the right temperature before being pressed together? What's the implications of that?
Right. So if you don't get to that glass transition, if you will have a cold spot in your weld. You press it together, and then you have a very poor weld or not a bond at all. and then you have a weakened part, and depending on how critical that part is, whether it's liquid containing or it's under stress or whatever the case may be, you have a weakened portion of the part. And if you don't know that, obviously this can lead to all kinds of issues in the field once the part is being deployed.
So, Mark, your customers that are utilizing your welding machines and that have this integrated quality inspection technology, this thermal imaging, uh, how can you explain or describe how they interface and work with it? Are they making adjustments, or can they rework a part? I guess how do they work with the inspection information that they receive?
So great question. Thanks, David, for that. Yeah. So in because you're able to see the weld in real time, and you're knowing when the machine is set up, and you set it up to nominal, and you trend off that, it allows the customer to do his failure, go to a failure mode to understand where that spec drives off acceptable parts and into scrap. And because it's hard to we haven't had a lot of success with going back in and re-welding parts that's already been welded. We chase nominal. We make adjustments to stay on nominal. That's where the sweet spot of the weld is at. And we can actually see the two surfaces and how the weld is penetrating both surfaces to understand that bond that between the two surfaces. It allows the customer to always know that the parts that are coming out will not leak if they're holding some type of fluid. Because when you go into these things through the prototype phase, you test and set these machines up to be able to understand where the failure modes are based on the welding that's going on. So you have an upper control limit, you have a lower control limit, and that's based on the prototyping and setting the equipment up.
Gotcha. Okay. Wow. Interesting. I so as you mentioned earlier, this, and I love this concept, Marcus, that you touched on. I mean, we're talking non-contact, not only welding, but non-contact inspection, which is pretty cool, both based on infrared technology, which as well is, I say, pretty cool. But, and as you mentioned, Mark, earlier, um, this works on parts that are contoured, I guess, complex parts,
Correct.
right? uh, where it's difficult to make that contact. Um, so um, I talked about this a little bit in our intro, and that is these quartz glass infrared emitters. Maybe you can explain to our, I know what those are because I've seen your machine and how it does the welding, but maybe you can explain to our audience that doesn't know anything about these infrared emitters. What are those? And maybe, like, how many are in a machine to do, let's say, a standard part like a grill, if you will, off an automobile.
Yeah. So it's they're like they act as insulators to be, because there's a lot of heat there. So they're actually acting as an insulator there. You can have a bunch of them. I mean, it's really the surface you're trying to bond to. And to your example, you could have up to 100 emitters in there, um, making all this work.
So these emitters are, if I understand correctly, they are essentially in the same, I guess, geography as the where the weld needs to
Absolutely.
be, and they're emitted infrared radiation that is creating this melt in that very particular specific area by not making
Correct.
contact.
Correct.
That's pretty. I keep saying it's cool. It's actually hot that this happens. So, um, what might be a failure point in one of these systems, right? And I imagine that's what we're inspecting for. What are the causes for the variation outside of the nominal, settings?
Well, before you can put this product into the IR welder, it comes from a different process. And if that process is not repeatable or it's not maintaining a certain upper and lower control limit when it makes those parts, you can have a failure mode in the IR welder because the process that they were originally molded under is a moving target. And so you might have to be making adjustments to be able to bring them two surfaces together. If the process changes and it changes the part, then it's going to change the IR welder. We're doing things right now in our R&D department that is trying to recognize the product coming into the IR welder to be able to make adjustments if it needs to be, but we're not there yet. There's different things that we're trying to do that allows us to understand the level of the part going in there in real time and having the machine react to that.
Wow. So that's interesting, Mark. So if I understand this correctly, the inspection system could potentially detect variations that are happening upstream before the part even arrives at the welder. That there's some kind of variation that happened further upstream in the process. Is that right?
That's correct. I mean, if you think about the two surfaces, if they are slightly different and you're heating them two surfaces up anyway, if we can read the differences before the product goes in there and the machine can correct to make sure that it's overcoming those things with the bond and the mechanical weld, then it's making the adjustments in real time to overcome certain defects that happen further down line before the output comes out of the IR welder. So it allows us to adjust and overcome any kind of defects that the two products may be seeing.
Gotcha. Okay. Wow. Interesting. Marcus, I'm. Can you talk to our audience? Can you share with our audience what makes up an inspection system? What are the components? And maybe this is I know this is a big question and it can get real deep. What goes on from like a mathematical side to determine this is good, this is bad?
Right. Yeah. Great questions and loaded question too.
I'm sorry.
So yeah, let me unpack that. So let's start with what makes up a system, right? So it could be one or multiple cameras, depending on how large the part is, how complex the part is. Because what you want to make sure is that you have enough pixels from the camera projected onto the part, so that you have enough spatial resolution to capture temperature variations in the different weld areas. And some parts, every part has a different aspect ratio, right? Some can be very long, some can be square. So we look at this first and say, okay, how do we best divvy up the areas that we need to inspect, and then perform some calculations on saying, okay, how many pixels do we have available on a camera, let's say 640 by 512 pixels, and how small of an area do we want to inspect? What's our smallest area of defect that we're concerned with, right? So that depends on the width of the weld and some other things like how critical is that weld in that area if something were to go wrong. Especially if you have parts that contain liquid, obviously it's super critical that they can't be the slightest little leaker. It needs to be completely sealed. So really it needs to be an initial evaluation from that perspective to see how do we divvy up the area and how many cameras and resolution and such do we need. Then those cameras go into a computer. And this could be in the shape of a panel PC with a computer attached to it. It could also be an industrial computer separately in a separate screen. That really depends on the needs of the machine and the presentation of the data. And then we have our own in-house developed inspection software running that snaps images from these cameras at the right point in time when typically these infrared emitters come on. They have a certain dwell time to bring the material up to a certain point of to that glass transition area. And in that moment, we're getting a trigger signal from the machine and snapping images. And then the evaluation on along those weld lines is starting and making sure that, okay, have we reached the right temperature in these areas? So there's a locational analysis, where is it located, but also a temperature analysis to say, because we need to have an awareness, or the system has to have an awareness of what is a weld area. We don't care if next to the weld some temperature changes are happening. We need to really determine the weld lines themselves and make sure that there's no, problems arising there, essentially. And then there's a component of that inspection system that needs to have the ability to communicate with a machine controller so that the machine understands, okay, inspection is done. Is the part good? Is the part bad? Sort of thing. So we have, in a sense, two different things, and Mark touched on this. One is really the true inspection that basically just says, hey, is this good or is this bad? But you can push this further and make it actually a process control system where, like Mark said, if the parts are coming in very largely in temperature, that has an impact on the welding, because you can't just apply the same amount of energy over the same amount of time. If the parts come in 10 degrees colder, that is, that requires more energy to get it up to the same temperature. So you could look at this and basically analyze this and say, okay, if this comes in 10 degrees colder, we have to either extend the length or increase the energy going into the part in order to offset that difference in part variation coming in. So then you spill over into the process control rather than just inspection. But either scenario is possible with these inspection systems.
Gotcha. Okay. Wow. Very cool. So maybe not just is it good or bad, but let's adjust something in the process to correct. That's really interesting. I know there's some secret sauce, in the mathematics side of things. How does that work, Marcus? Can you describe that kind of a high level or basic sense, like mathematically, what's going on here?
Yeah. So infrared imaging is quite tricky because a lot of people look at this from the understanding of, I have a thermometer, right? A thermometer is a single point temperature device that gives me a temperature. And I intuitively trust that the reported temperature is correct the way it's reporting it. With a thermal camera, because it's a non-contact optical measurement system, it gets a lot more tricky because of the involved physics. We have something that folks that do thermal imaging understand. It's called emissivity. So we have something, thermal cameras really just don't measure temperature directly. They measure infrared radiation and then convert the radiation, the energy that it's capturing, into a temperature reading. And there's very complex math behind it. It's not very linear at all. There's the Planck law and all those kind of things involved. So now the issue becomes, okay, first of all, what angle am I looking at the surface? If I'm having an angle introduced, it's impacting my emissivity. So that's the ability of a solid material to radiate that infrared radiation. So with angle changes the amount of energy that I'm getting captured in the camera. Therefore, the reported temperature, the apparent temperature, is changing. I need to have an awareness of it and correct for that. That's one thing. The other thing that basically impacts the emissivity is also the type of material. I mean, most plastics are pretty forgiving. They have pretty decent emissivity, so that's a good thing. It gets a lot more difficult if you have metals involved. They tend to be much lower on the emissivity scale. So all of this needs to be considered before we can even rely on the temperature readout that we have, right? So there's a lot of physics and understanding of how to compensate for that involved. So it's not just you point the camera at something and that's your temperature, end of story. No, there's lots and lots of variables that play into this that you need to consider. So, and then it goes further in the actual image processing. Thermal imaging really is a mixture of image processing in terms of spatial awareness of where you're measuring, but also a signal processing task where you sometimes take not just a single snapshot, but you may be monitoring temperature over time and draw some conclusions from that. So you have really the two worlds of signal processing and image processing converge, and you can draw information from that as well. So it gets quite tricky to really, have the system tell you the truth, if you will, and make decisions based on that.
Marcus, listening to you describe that just reminds me the value that Movitherm brings into this space with over 15 plus years experience working with thermal imaging cameras. You understand all this, and that's part of the value that Movitherm brings into this partnership by having that understanding combined with the the expertise of HA Industries on the emitting side and bringing that together. It's again, it's a fascinating non-contact on both sides from a measurement and also from a welding perspective.
Just to add to that, David, it's because when Marcus brought up the flexibility that you have, that really is what we are trying to capitalize on right now, is that flexibility to understand and if for lack of better words, dumb the system down because of the the certain trick that you have to overcome with some of this stuff. Is at the same time, there's a lot of flexibility in there to overcome a lot of that stuff and make it more user friendly, and that's what we're stepping up to the plate to do.
Awesome. No, thank you, Mark. I have an interesting question for us, gentlemen. Well, for you, not for me. As we kind of wrap things up here with regards to our discussion about infrared welding of plastics and utilizing these emitters, and then also utilizing infrared to inspect that process. And this has to do with where do you see things going? And I think you kind of touched on a little bit, both of you did, where you were talking about, moving things from just a QA check to a process control type setting. But I'm interested, and I'm sure our listeners are as well, as like, where do you see things going? And that's kind of a broad question. And so, Mark, I'd like to ask you, because you have a broad, business that you're covering. You mentioned some of the different industries. You do a lot more than just infrared welding. That just happens to be our subject matter for today. But in general, and maybe this is from, helping customers, trying to automate processes and things like that. What are some of the trends that you see out there? Or maybe what do you where do you see the future headed when it comes to automating processes and simplifying things, which is kind of what I see you guys do, which is part of the DNA at Movitherm. It's like simplifying the complex, making it easy for customers to essentially perform or accomplish a task. So I don't know, kind of a broad question, Mark, but what do you see happening out there?
To me, getting things to trend moving forward, to be able to read the weld in real time and how it's trending, and being able to auto-correct the trends. And because one of the things that all my customers have to deal with is product that is defective in the field. And they didn't want to ship it that way. It just got shipped that way because of either the inspection systems are not where they should be. They're manual. They don't have all the capabilities that they need to have. And I just see that once we continue to take this down the road of true inspection in real time and be able to set that machine up that it's going to tell you to ship it or scrap it, that has to be a major comfort zone to my customers, to know that that decision is made on their production floor and not somebody at a plant that's receiving this that finds out the weld didn't hold, the weld was leaking. And I want to have the data in real time to my customers that says, you've passed. Nothing after this. unless we have a damaged shipment that's out of our control, that this thing is going to work as intended out in the field.
Excellent. Yeah. Marcus, same question for you. Like what, and maybe a little more specific to this topic that we've been talking about. Where do you see this could go? Where do you see some of the trends in this space?
Yeah, I share Mark's vision that there's so much upside opportunity for actually doing intelligent process control and really creating additional value above and beyond inspection, because inspection is really just a pass-fail situation, right? It doesn't have in its on its own. It doesn't have the ability to control anything or to change the outcome other than saying, don't ship this part, ship that part. But if we push this further and we start to do the process control and we say, oh, parts coming in a little colder, or the pressure needs to be a little higher over here, or whatever the viable variables are for the process that have an impact on the quality of the part. Once we bring it to that level, then we can also act on in real time doing the process and change the outcome of the process, not just saying, oops, that one didn't work, right? So that's the next level. And then pushing this further, you could go, if I really shoot sky high, what you can do is you can actually have a system that, rather than performing R&D on a part, you can have the system analyze the parts that are coming in, run a few welds, and figure it out itself and self-tune, and basically have then, after a few cycles of learning, you can then push the button and say, okay, now go and weld. So that would take the the domain knowledge and the black magic that people have intuitive knowledge about, that have been in the industry, and starting to bring this in and automate this to the level, and really, I think, change and impact the industry there.
Marcus, did I understand you correctly? Is that called artificial
It
intelligence?
can be.
Just to add to that, David, what piggybacking off some of the things that Marcus said is what the customer now can do when they see that product coming in that's slightly different. They can go upstream and correct it in the other process that's causing the problem. So at the end of the day, you don't want this machine auto correcting every part. So it should teach them what they need to do upstream as well to make sure that there's no fallout up there on the other processes.
Yeah.
That's
And Dave, to
interesting.
your word,
Yeah,
whether I
Marcus.
call it AI as an artificial intelligence, I would recoin that phrase, and I would call it II as an intuitive intelligence.
Oh, well played. Well played. This is an ongoing discussion that we have regarding artificial intelligence and how it plays in this space and how effective it is. So, anyways, I'm teasing a little bit, but thank you, Marcus. Well, gentlemen, I I'm going to give you the opportunity to offer any final words before we wrap up today. But Mark, again, thank you for taking the time out of your schedule to join us. Beyond that, thank you for the opportunity that we have to partner with HA Industries, and I say we, Movitherm, in providing an inspection tool for your welding technology. Any parting comments, Mark, as we wrap up today?
HA appreciates the partnership as well. Our visions are aligned. We will get to where we're going. The passion is there. I think that the more traction IR can get in the public to understand that this is new technology, this is going to be a better way of putting parts together. The more traction we can get and get that word out there, I think the better off we'll be in a production environment with how you bond two parts together.
Thank you, Mark. In fact, with that note, I would encourage our listeners to go to the HA Industries website. There's actually a great video there that covers this application of this infrared welding, and maybe we could even highlight that as we post this podcast, so folks can go there and see that. But there's a great video there to actually see the process, the machines that you guys
Mhm.
produce. Marcus, any comments, parting comments as we wrap up here in this episode?
Yeah, absolutely. Yeah, this was a great conversation, and we appreciate always having industry partners being on our podcast and really getting their point of view across. And it's not just us talking about things to really provide that perspective. And we're also equally excited about this partnership and see what we can come up with together and actually push that that boundary and create the next generation technology out there and help manufacturers to produce better parts, higher quality, and at a lower cost. That's really our job.
Yeah. Awesome. Thank you, guys. Well, to our guest, that is it for today's episode of the Thermal Review. Thank you for joining us, for listening, or if you're watching this on YouTube, for watching us. Thank you again to our guest Mark Erndt for joining us today, and again sharing with us a little bit about the HA Industries story. Uh, Thank you. We appreciate that, Marcus, as well. Thank you for helping us understand again the power of infrared imaging, infrared inspection. Uh, Mark, it's interesting because you talked about getting this word out. I still feel like this technology of infrared, whether it's imaging or welding, this technology has been around for 50 years plus, but it still seems like it's the newest unknown tech on the market, and that's what makes this so fun. Uh, Essentially spreading the word and educating folks about the capabilities. Um, Thank you again for listening in. Um, if you want to learn more about any of the thermal review podcasts, we encourage you, like we always do, to come to our website and you can check out the thermal review there. You can also visit your favorite podcast platform and subscribe to us. And we appreciate you for doing that. We also want to give the shout out to those who offer comments and recommendations and suggestions on future episode themes. Thank you for that. We appreciate you sending those in, and we will be covering those topics that have been submitted. So thank you for that, everyone. Thank you again for your time today.